theme for the second half of this chapter, you're going to find this section once again, a lot easier than what we did in the first half of the chapter. We've got three big theorems here. Two of them are very closely related. The third one is a little bit different, but they're all pretty basic and simple concepts that most people get very quickly. And just the names of the theorem should tell you they're not terribly difficult. Triangle longer side theorem and triangle larger angle. I can't speak today. I apologize. It's been a long day. Basically what it comes down to, these two theorems, I'm going to sum them up this way. In a triangle, the biggest side is always opposite the largest angle, and the smallest side is always opposite the smallest angle, leaving the medium side opposite the medium angle. It's just kind of common sense. It's not that difficult. So, for example here, if this side is 8 and this side is 5, then the angle opposite C must be larger than the angle opposite A, because 8 is bigger than 5, so angle C must be larger than angle A. The angles opposite must be larger. Same here. If this angle is 50 and this angle is 30, then the side BC must be bigger than the side AB, because the longer side has to be opposite the larger angle. The most difficult thing about this section is that we deal in this section with inequalities instead of equal situations. So for the first time this year, we're going to use those greater than, less than signs. So we aren't saying sides are equal, we're saying sides are unequal, and we're putting them in order. The other thing that's difficult is we need to pay attention to what it asks us to do, in this case, from smallest to largest. So we want to go smallest. We want to list the angles of this triangle from smallest to largest. We are told the bottom edge of the mountain is 32. The left slope is about 24. The right slope is about 26. So I know all three sides. Given that information, so big long story problem, that's what it boils down to. What is the smallest angle going to have to be? Angle L, angle K, or angle J? Well, the shortest side is right here, 24. So the opposite angle, that doesn't show up real well, but I hope we can see it. Maybe if I do it in this. There we go. Okay, the opposite angle must be the smallest angle. So angle L is the smallest angle, so is less than, okay, it's the smallest. The next biggest angle has to be across on the 26th side, so that's angle J, is less than the largest side, angle which has to be across on the largest side, angle K. So we could do it that way. Also, since it just asks you to list them, you could just say angle L, angle J, angle K without the inequalities. That would be a list of angles from smallest to largest, and that's just fine. But deciding which one's smallest, which one's largest, not that difficult. List the sides from shortest to longest. Saying, wait a minute, I only know two of the angles. Yeah, that's true. Oh gosh, what are we going to have to do? Find linear equations, slopes, distance formula? Nah, none of that. Just got to find the third angle. If I know two angles of a triangle, I know the three angles add up to 180. So if this is 51 plus 47, or 51 and 47, 51 and 47, that's 98 degrees used up. How many degrees left are for this third angle? Oh, that must be 82 degrees. Because they have to add up to 180. That's not too tough. Now, given that, and I want to go from shortest to longest, I'm just going to list the sides. What would be the shortest side? Well, I have to identify what the smallest angle is. The smallest angle is a 47, so the shortest side must be DF. What's the next longest side? Well, what's the next largest angle? The next largest angle is the 51. So that's EF is next largest side, next longest side. And the largest angle is F, so the longest side must be DE. It's really that difficult. If you just take your time, slow down, pay attention, these are pretty simple problems. Again, list the angles of PQR from smallest to largest. Not obvious in the picture which is the biggest and which is the smallest, because it's close to an equilateral triangle, but it's not. So the smallest angle here would be angle Q. The largest angle is going to be angle R, which means the middle angle is angle P. Some people prefer doing it that way. Instead of going smallest to largest, they identify the smallest. The largest, whatever's left, must be the middle. Same thing with the sides here, from shortest to longest. The longest side is obviously RT. That's the longest side. The shortest side is going to be opposite the 29-degree angle. That's ST. And the middle side, therefore, is RS. That's how we do it. Not a lot of equations, no distance formulas, no coordinate plane. It's just working like that. Second and more interesting one is the idea of what sides can be used to make up a triangle. Can I take any three segments and make a triangle? And the answer is no. There's actually a restriction here. For example, if I had sides that were, say, 15 units long, and another one that was 2 units long, and another one over here that was only 1 unit long, how could I possibly get the 1 and the 2 to ever meet and make a triangle without bending that 15 side? And then it's not a triangle anymore because we've bent the side. Some sort of a quadrilateral or a curved shape or something like that. So I can't just take any three sides. So what it boils down to is that the sum of the two shorter sides, they've got all these formulas here. We don't need to memorize all these formulas. Don't worry about that. Don't worry about the formulas. Basically, the sum of the lengths of the two shorter sides, so short side plus short side, must be greater than, not equal to, but strictly greater than the longest side. Longest. Longest, we could write the longest side too. Okay? So the sum of the two short sides must be greater than the length of the longest side. That is required for any triangle. So for example, could I have a triangle made up 5, 6, and 7? Absolutely I can, because 5 plus 6 is greater than 7. Could I have 5, 6, 12? Could that be a triangle? Well, no, because 5 plus 6 is not greater than 12. See, we're interested in greater than or not greater than. Same with 11. 5, 6, 11 would not work, because 5 plus 6 is not greater than 11. Equal to doesn't work. It has to be greater than. The sum of the two shorter sides must be greater than the longer side. Also, please remember, the sides aren't always going to be listed, shortest to longest. I could go 15, 13, 3. 15 plus 13 is greater than 3. Yeah, that's great, but that's not the two shortest sides. The two shortest sides are 13 plus 13 and 3. And 13 plus 3 is greater than 15, so yes, we are good. Okay? This is interesting, though. A triangle has one side of length 14 and another side of length 9. Describe the possible length for the third side. So if I know two sides, what is the range of values that we could use for the third side and be legit for the triangle? Well, actually, this is very, very easy to calculate. Again, there's all sorts of formulas, but I'm going to boil it down for you very quickly. The two sides I have are 14 and 9, right? That's what we're given. So my third side must be in the range. My third side, I'm going to call X, must be in a range where the lowest number possible is the difference of these two numbers. Bigger minus smaller, we can't have a negative length. And the upper value here is the sum. Notice these aren't greater than or equal to signs, they're just greater than signs, or less than signs in the case, as this case is. But the difference in the sum. So in this case, my third side, 14 minus 9 is 5, 14 plus 9 is 23. The range of values for the third side, it must be bigger than 5, but less than 23. So bigger than 5. Why? Because 5 plus 9 equals 14. That's not big enough. It has to be bigger than 5. 5.1 would work. And 23, why? Because 14 plus 9 equals 23. 23 would not work, but 22.9 sure would. So it must be bigger than 5 and less than 23. Greater than the difference, less than the sum. Pretty straightforward. A triangle has one side of 12 and the other side of 20. What's the possible range for the third side? There's really not enough space here. So I'm going to try to get a little extra space here so we can answer this question. There we go. Sorry about that. What's the range of values? Again, pretty simple. Notice my arrows here are always pointing to the left. They're always less than symbols, less than point left. The numbers I have are 20 and 12. So the lower number has to be the difference. 20 minus 12 is 8. The upper number has to be the sum. 20 plus 12 is 32. There's my range of values. Done. That simple. Not a whole lot of work involved. Is it possible to construct a triangle with the given side lengths? Is the short plus short bigger than the long? 4 plus 9 is greater than 10. So that's a yes. 8 plus 9 and 18. 8 plus 9 is 17. So it is not greater than 18. So that's a no. 5 plus 7 and 12. Is 5 plus 7 equals 12, but it is not greater than 12. So that's a no. That's triangle inequality. And that's what we're doing today. We're doing things with list side shortest to longest, find the length of the third side, is it making a triangle? Really, compared to what we were doing first half of this chapter, this is really, really nice stuff. So hopefully you're finding it as easy in class tomorrow. But if not, remember, we're always here to help you. Learning Center is always open. Make sure you avail yourself of all your opportunities. We'll see you in class.